Good afternoon. Good afternoon, and I am thankful to SIA for inviting me to this session. It's a very important topic, enabling satellite IoT systems in infrastructure and connectivity solutions. So IoT is a different domain, satellite is a totally different domain. IoT is basically sensor based. It's very small devices making very huge number. Satellite is totally a different ballgame. So how they can work with each other, how we can marry satellite with IoT, and how we can reach the. So this topic is a very new topic, and right now not much work has been done. It is at nascent stage. So I have very three eminent panelists: Mr. Gianluca Redolfi, CCO, Satellite, Mr. Jaswant Singh, Lamhas, and Mr. Prasanna Iyengar from Skylo. So I will start with my brief presentation now. So in India, satellite communication, it started way back in 1982, 1983, and now we have a very mature ecosystem. Now SATCOM is being provided by about 18 indigenous satellites and 19 foreign satellites in India. So when I am talking SATCOM means telecom as well as broadcasting service. So for telecom services, the Department of Telecom or DOT issues authorization. So for M2M or IoT ecosystem, we need both good telecom connectivity and good M2M service framework. So we see that these are the various layers: sensor layer, connectivity, service, application, and end user. So this connectivity layer, this is the area where the Department of Telecom works in both the domains M2M as well as satellite. Not working. आप वहां से मूव कर दीजिए. You can move them from there. Yeah, so our department has got satellite service provisioning. There is a regulatory framework, and they can be provided through four types of authorization: commercial VSAT CUG, then GMPCS, global mobile personal communication service, then captive VSAT, and then in-flight maritime and connectivity. So these are the major authorization through which satellite services can be provided in India. This is the number of various licenses, like we have got 23 captive VSAT and 12 commercial VSAT licenses. For mobile services, there is only one BSNL, it is providing service, that is GSPS, Global Satellite Phone Service. And the total number of VSAT is about 2.53 lakh for commercial VSAT. Now this is about commercial VSAT CUG service. The scope is to provide data connectivity between various sites scattered within the Indian boundary, and it is limited to a closed user group, and that it can also be used for providing backhaul connectivity. So it is very useful for M2M service backhauling. Now recently the licensee may also use the VSAT terminal to aggregate the traffic from M2M IoT devices, aggregator devices of the CUG, and also to provide backhaul connectivity. So now M2M services enabling is already there in India through VSAT. Then one more thing is that eSIM, that is Earth Station on Moving Platform, that is also possible under this authorization. Next is the captive VSAT. Captive VSAT, almost the same kind of conditions are there, except for that network will be used only for internal communication and non-commercial purpose. So they cannot provide any backhaul connectivity to outside their group. Then we come to the M2M IoT service regulatory frame. So the department issues permission for providing M2M services. So there are these 4 types of authorization: M2M service authorization under unified licensing. So here the authorized entity, it can own the network and can provide connectivity. It can also use LPWAN, low power wide area network, or equivalent technology using unlicensed and also licensed spectrum. Then second license is M2M service, that is virtual network operator. Here the authorized entity can use the network of the M2M service authorization. So they may not set up their own network. Then third is the M2M service registration. It is a very light touch registration but they cannot set up their own backhaul or transmission network. They will have to take telecom facilities from telecom service operator. And the fourth is WPAN, WLAN, wireless personal area network, wireless local area network connectivity. So they use this connectivity for M2M devices only in unlicensed spectrum. So mostly M2M service registration and WP, WLAN connectivity provider, they are almost one and the same. Then these are the recent initiatives in satellite authorization. One is the simplification of the process. Now the clearance is very simple. There is no multiple name scrutiny by the different agencies. There is no per site clearance for wireless operating license for VSAT. That is also done away. Then various steps have been taken for boosting satellite-based communication services. Like scope of commercial VSAT has been enhanced, and now fully mobile or pause and move, both types of services are possible. Then enhancement of scope of commercial VSAT, so they can use their connectivity for backhaul through VSAT for cellular, mobile and Wi-Fi. Then data speed restrictions are also removed. Then earlier there was rupees 20 lakh per transponder charge per year for TV and telecom. That has been done away. And antenna testing of this satellite antenna testing is also on self-certification basis, and there is no charge for it. Now for boosting the M2M based IoT communication services, now satellite license scope has been enhanced to enable satellite based M2M services. VSAT may be used to aggregate the traffic from such devices. M2M devices used in any architecture. Then the enablement, we believe that such kind of enabling steps will pave way for introduction of satellite-based IoT devices in all the sectors. Then in Indian space policy also, it came last year in April 2003. There have been many reforms. The sector has been totally open to non-governmental entities now. So government notified last year. It is a very overarching composite and dynamic framework. Now Indian consumers of space technology services, now whether they can take these services from both private and public. So they can take satellite, they can take space segment from private or public sector, from any entity. Now the non-government enterprises, they are being encouraged in a big way to offer national and international space-based communication services. They can do it through cell phones or procured or leased GEO and GSO communication satellites. They can use Indian orbital resources or non-orbital Indian resources to establish space objects. Then Indian National Space Promotion and Authorization Center. It has been established, so it is a unique type of institution. It regulates as well as promotes. However, the regulatory framework for telecom service, they are regulated by the Department of Telecom, and for broadcasting service, it is regulated by Ministry of Information and Broadcasting. So this is a report on IoT market. This is a global satellite IoT report. So as per this report, the satellite IoT subscribers, they reached 5 million in 2021. Only 2% of the global satellite connectivity market in US dollar relates to IoT connectivity. However, we believe that with the rise in LEO and MEO, it will have a huge boost. So the market, the global market is expected to reach 1 billion by 2026, and 1 trillion IoT devices are expected in the network by 2031. As regards the Indian market scenario, as per an estimate, it was around 5.6 billion US dollars in 2020, and it is expected to reach 10.2 billion US dollar in 2024. So we believe that as the regulatory framework is very light touch and very enabling in India for both M2M and satellite, we expect a huge jump in the IoT, in the satellite IoT market in India. Thank you very much. Now I invite Mr. Gianluca Redolfi, CCO, SATELIOT. This SATELIOT is a LEO satellite communication service provider to offer global satellite IoT connectivity with 3GPP. They also offer IoT connectivity over standard 5G. So their constellation serves as cell towers in space, expanding mobile operator coverage and providing global connectivity. So now over to Mr. Redolfi.
Thank you very much. Hello, everybody. Okay, today we're talking about how the IoT world is changing. So there's something that we call the unstoppable willingness of measure everything, which basically is if we want to improve something, we need to measure it. And this is absolutely happening in all the verticals that we know in all the industry around the world. Okay, so in this slide, you can see. Thank you very much. We can see in logistic, agriculture, livestock, environmental utilities, oil and gas, and many others. There is a universal trend of measuring and improving. The issue we are having, I think you need to put in presentation mode so I can. Okay. No, it doesn't work. Can you make presentation mode? Which is Control L. Okay, thank you very much. So this digitization of the verticals is asking to have, of course, a way to collect all the information and bring it back to the layer of intelligence. And the coverage of cellular is an issue because 80% of the world doesn't have cellular coverage, and there's a need to have their connectivity. So far, actually, I mean, we saw 5 million, we have 4 millions, but that's more or less what we evaluate in the world. In the last 30 years, on satellite IoT, around 4 to 5 million devices have been sold. Okay, so the connectivity is very limited. If we think about IoT connectivity on cellular, we are on a multi-billion situation where we have 2, 3, or 4 billion devices that are connected over cellular. So SATELIOT is the constellation that connects globally in a standard way all the 5G IoT devices of the world, even if they are out of the coverage of the telecom operators. So how it works? We have a seamless way of extending coverage of the telecom operators. We have our own core network, we have our own constellation, and the devices, whenever they are going out a normal cellular device, you don't need to have a different one, and that's the big change. Probably we are the first and only own constellation that you don't need to buy a different device to connect to the satellites. You can use a cellular device. So your cellular device, whenever it goes out of coverage, it connects to our constellation, it goes back to our core, through a simple roaming connectivity, roaming agreement, you still have connectivity. This is very easy. It's very simple for the final customer. It's the same device. It's the same experience for the final customer. And for the carriers, is a simple way of extending our coverage. We have our own constellation. That's one of the satellites. We are launching actually next week few satellites from Vandenberg in California. So it's going to be the first commercial LEO satellites on 5G narrowband IoT in history. So that's a big milestone for the world. Global coverage, and that's one of our friends setting up the satellites. We've been working with Amazon, AWS. Our core network is in AWS. We've been testing, and we demonstrated the end-to-end connectivity through Telefonica SIM. It means that a device with a Telefonica SIM was able to connect to Telefonica normal network, switch it over to the network over satellite, which is a huge achievement. Our go-to-market is through the MNOs, through the carriers. So we are partnered with them. You're going to see a slide where we're going to show to you our footprint. We have started, nevertheless, before the launch, also signing binding contract with the final customers. And we're going to convert them into revenues as soon as we're going to be commercial. And in this 1 year and a half of activity of pre-selling, we sold already 4 million connected devices, 4 million connectivity, which is much more than what has been sold in the previous 30 years. This is incredible because it means that the different way of doing things, where you don't need to have a very expensive device, you don't need to have a very costly monthly price, can really enhance the possibility of having connectivity for any use case in the world. You see in orange here our footprint of agreements with the telecom operators. So we are covering basically most of the world. And we say this: the anything startup is there to disrupt the SATA industry, and there's no way back. We really think that the fact that there is the need to buy a specific device to connect to the satellites and the fact that there is the need of paying a lot of money because there's no economy of scale, and also that the satellite industry and the cellular industry are two different industries, is not going to be there in the next future. So that's the change of paradigm. For the final customer, we continue using the same device. The satellite coverage is basically at a terrestrial price. That's a big change, because if it's too expensive, then you cannot use it, and you stay with just a few million lines. And for the carriers, we offer additional revenues without any investment in capex, and it's very easy the interconnection, because it's a normal roaming standard GSMA agreement. And that's all, because we think a connected world is a better world. Thank you.
Thank you, Mr. Redolfi, for sharing his thoughts about how they are connecting the world with satellite, how they are connecting IoT systems with satellites. Now I invite Mr. Jaswant Singh, who is Senior Vice President in Lamhas.
Good afternoon, everyone. And I'm thankful for SIA for having me here on this occasion. I'm from Lamhas Satellite Services. We are over 20 years old company into satellite communication. We have been giving services to the broadcast and media industry, corporate house, sports bodies, through satellite, through terrestrial, and through internet. See, the background of IoT is, say, way back about 15 years, but gradually it is picking up. The deployment of IoT devices are gradually picking up through different connectivity methods like terrestrial and other modes. But the satellite IoT is a recent development, and gradually it is picking up in India as well. The IoT I take in two categories. One is the critical applications, and another is non-critical application. So when we say non-critical, it is where the data security and the network security is of paramount importance. The non-critical applications are like your say logistic companies and other applications where especially the mining another area where large deployment is there, but the critical application where security of network and the device is important, that is where our focus is. And we'll flip through this. See, this is a network architecture of satellite IoT. It is through GEO, LEO, and the MEOs. There are use cases where critical IoT is being used, especially in government sector like our Indian Railway. In India, we have passenger trains, the goods trains, and the ARTs, that is accident relief trains, and over 7,000 railway stations. So all put together, it comes around 30,000 installations. And each unit, if you talk like the railway trains and the stations, the number will be in, say, over 1 lakh devices. So if we put the IoT into the IoT devices on each, say, trains or the stations for monitoring the traffic management, There the data security and the network security is very critical, and it can provide real-time information to the rolling stock, to the passenger trains, and for traffic management system. There it can give very vital information on time and real time. The second bigger use case is our border security forces. We share land borders with 7 neighboring countries, and our total border is over 15,000 kilometers. So there the conventional IoT is based on the terrestrial system and other interfaces not going to work. In those far-flung remote areas, we need a robust, resilient satellite system IoT devices. There, they can really be helpful to the security forces for giving them the on real-time information about the troops, about the patrolling vehicles, and special logistic mobilizations. Plus, it can give real-time connectivity, real-time two-way connectivity, that is voice and data, in those areas where the terrestrial is not at all there. And our security forces are mostly on the borders where the terrestrial is not there. So that is the area where we should think of deployment of satellite-based IoTs. Third use case is our NDRF and SDRF, National Disasters and the State Disaster Agencies. Where when there is a real disaster situation, the terrestrial, especially in the stormy conditions, it snaps, it doesn't work. So in those conditions, the satellite IoT-based solutions are the preferred one, where you can always have the real-time connectivity, and they can give the real-time picture to the decision maker at the headquarters. So those are the area where we should seriously think of devising the communication system based on the satellite IoTs. The fourth biggest use case of satellite IoT could be our meteorological department. You see the weather, the dots, colored dots, these are the deployment of our weather warning systems across India. And the numbers will be in millions. Because every observatory have devices, but how do they transmit the information to the station where the informations are analyzed and the advisories are released? It is through communication. So when there is a bad weather conditions or other disasters, the communication doesn't work. So those are the areas where we should really think of putting satellite IoT-based devices for the connectivity, so that the sensors can give real-time information to the headquarters where the information can be analyzed and advisories are released on time. These are the IoT device connectivity technologies available. It is through satellite, Ethernet, LoRaWAN, Zigbee, Z-Wave, cellular, Bluetooth, and Wi-Fi. So, our area of interest is through satellite, providing IoT services through satellite in remote, far-flung areas. And there are factors affecting the choice of satellite connectivity. IoT device connectivity. See, in city areas we have different communication available. The terrestrial is available, the Ethernet, the internet is available through fiber. But when we go to remote areas, we have only the option of satellite. And the factors which affect is the cost. At what cost? Suppose we are in say city area. I would not prefer the satellite communication because the fiber is available at cheaper. The internet through other modes are available at cheaper rates. The conditions, again the conditions are the weather conditions. And next the infrastructure. As I mentioned earlier, in remote areas it's only the satellite available, but in other area, metro or the city area, other communications are available. and the bandwidth, the kind of device we are putting in depending upon the application. So if the data is more, we will prefer the other modes of communication, but if it is low data rate, then the satellite is preferred one. The coverage area, again the coverage, the satellite communication is available across the globe, irrespective of the geographical conditions. And the battery condition. Battery consumption is, there are devices, because these are very low power devices, they can operate on say PV interface or the low power batteries. The IoT connectivity technology comparison. There are technologies available, and each technology has its own applications. Depending upon the use case, you select the technology and devise a solution. The IoT satellite, the satellite IoT have its challenges, and the challenges are the infrastructure is limited. The data privacy and the network privacy is a big challenge, because when we go for the critical applications, the data are very important. If the data are breached, the whole purpose of deploying satellite IoT is failed. The network security is also very important. See, the breach can take place at the device level and at the network level. So, if it is a device level, only one particular, say, organization is affected, where it is deployed. But if the network is breached, then the whole of the ecosystem is disturbed. Then there are still gaps in the IoT deployment. Skill is a big issue. As on date, there are very few professionals who are in the position of devising a robust, resilient IoT system. Then the lack of standardization. It is again a big challenge. See, the data format and the protocol standards are still not formalized. And our urge to the manufacturer on the dais is to have data formats and the protocol standards, so that interoperability is addressed properly. And the last challenge is in India, especially in Indian perspective, is the NTCT and TEC clearances. See, these are the satellite IoT is a regulated area in India, where you need to have the device clearances, and the NTCT and TEC clearance. It has a huge cost and it takes time. Few suggestions to address these issues are the device developer should work on the protocol and the data format standards. Then the request to the regulators are to find a mechanism where some devices which are internationally deployed and they follow the international standards on the protocol and on the security should be allowed without going into the MTCT or TC clearances. Based on the merit, and there are certain international labs, if they follow the standard practice and have the accreditation, based on those accreditation, they should be allowed in India, so that the faster deployment of IT ecosystem can be deployed in India. Thank you.
Thank you very much, Mr. Jaswant Singh, for presenting his thoughts about the size of the satellite IoT market and also giving us some sort of SWOT analysis about this market. So thank you very much. Now I invite Mr. Prasanna S. Iyengar, Senior Director, Skylo Technology. Over to Mr. Prasanna.
Good morning, everyone. Thank you especially to Mr. Agarwal and our organizers here. Since we're here to talk about IoT and satellite, and Mr. Agarwal spoke about the immense opportunities in IoT that exist today, at the risk of sounding repetitive, to what Mr. Redolfi talked about and what my other colleague talked about here, I'll try to join the dots for you. At Skylo, what we believe is that we are at an inflection point when it comes to using satellite or NTA networks, as we call them, for IoT use cases today. And I'll try to help explain why we think it is so. So it is not that satellite networks have not existed in the past. Satellites are not being used for communication. Historically, they have always been used for that. But if you consider outdoor IoT use cases that exist today, any IoT use case that you can think of, typically they have what are called as what my colleague referred to as LPWAN devices. These are low-power devices. These are devices that use a battery that has to last 7-10 years. These are devices that typically have a BOM cost of things like, roughly around the range of $15-20 sometimes for the core components, as small as that. These are also often devices that do not pay a lot for connectivity. So in Europe, if you take it as an example, over the 1 year, typically a cellular operator earns maybe about €3 from a particular IoT sensor that is deployed. In India, maybe it's 50 rupees a month. Maybe in other parts of the world, it's slightly more. So that's the order of expectation from customers when it comes to what is the connectivity cost for these IoT sensors. On the other hand, historically, satellites have always been expensive. These assets are expensive, the capacity is expensive. So to be able to connect the so-called sensors, machines and devices has historically not been possible. So that is problem number one, the cost. The second bit is about the hardware. Now, if you had to connect to a satellite in the past, typically you required an expensive hardware, maybe even a dish antenna, a specialized antenna that had to connect to the satellite, and you had to deploy it and incur high capex cost. Now, faced with this kind of proposition, there are three categories of use cases when it comes to IoT. Maybe there are a few different use cases that could connect to the kind of descriptions that Mr. Agarwal gave, where you have a VSAT terminal, you have a communicating gateway, and sensors and devices could connect. But for the vast majority of the rest, the choice is either the value is so less that you cannot afford satellite connectivity, and so you do not deploy or use that, or to use some kind of a local area connectivity and then use satellite as a backhaul. So hardware is typically was the second problem, why satellites couldn't be used historically. What is the third one? The third one is basically to do with change management. Now, a lot of the sensors, machines outside that are deployed, what we call as IoT today, can work with cellular technologies today. So for the large part, cellular is able to serve the need. So where satellite has to step in, areas where cellular is not available. So for any kind of satellite technology or NTA network to come in and assist, as Mr. Redolfi said, it has to work with the cellular ecosystem. So any connectivity that, if I am a customer and I deploy sensors worldwide, if I am working with Airtel or Vodafone today as a connectivity provider, I would expect that my relationship with them should continue and they should be able to provide me the same satellite connectivity in regions where my sensor needs satellite. Other places where cellular is available, they can use cellular. So this kind of hybrid or converged connectivity has always been a need. If you want to succeed in this market, that's a need. So these are the three problems, and why we believe we are at an inflection point is all three problems to a great extent are being solved today. Number one, new constellations are being deployed. Satellite costs are coming down. It's easy to manufacture satellites, deploy them cheaply, and it's easy to bring down the cost of satellite connectivity today. Second, hardware, and this is where Skylo has played a major role. We are now able to connect the same kind of cellular devices. The off-the-shelf device that you buy for the same kind of cost that I talked about, the device that connects to a cellular tower 1 kilometer away is now able to connect to a satellite or a geostationary satellite that is 36,000 kilometers away. To be able to do that, to be able to connect a device that operates on a battery to a geostationary satellite 36,000 kilometers away is the technology breakthrough. So that's problem number one solved. Problem number two, when it comes to VSAT terminals, so when it comes to satellite backhaul, people will typically talk about affordability in the range of gigabytes and megabytes of data. But if you talk about a sensor that needs to report its location, a sensor that needs to report pressure in a wall, you don't need megabytes and gigabytes of data. You're talking about bytes and kilobytes of data. So the use of protocols like NB-IoT that Satellite IoT uses and Skylo uses in a more efficient manner, we are able to bring down the cost of satellite connectivity to a fraction of the cost that it was earlier. Still more expensive than cellular, but when you combine it with a converged proposition, the cost to customers is very less. The third part, we believe that NTN networks, as they're rolled out, should be standards based. So we work with global standard based bodies. So we work in the 3GPP forum. Our implementation of NTN network is standards based. It uses the same kind of standards that your cellular technology uses today. As an example, the way we set up a network, it uses the same kind of base station that runs on the tower here. The same RAN, similar RAN, our own proprietary RAN that connects to the satellite is basically put on a station. So imagine, instead of having multiple towers throughout the nation that connects to your devices, you now have a single earth station where the base station exists, and this can now connect to one satellite above. So with 3 geostationary satellites, you can actually serve the whole world. We run the same kind of core network that an Airtel or a Vodafone runs today. The same kind of a 4G or a 5G core can transport devices from sensors and what we call as an NTN network. So what does Skylo really do? So what we do is basically we are a technology orchestrator and an NTN network operator. So today Skylo has a commercially live network in Europe, entire North America, Australia, parts of Asia, including Japan and adjacent regions. So by end of 2025, we expect to be covering the whole part of the globe and achieving global coverage for both IoT, consumer and automotive use cases through what we call as a direct-to-device connectivity. And we do this by solving the third problem also. Because we are standards-based, we don't sell our connectivity directly to our customers. We can partner with existing cellular operators, people like Airtel, Vodafone, Deutsche Telecoms of the world. We work with them. So we offer a roaming interface with them. So when you purchase a Airtel phone, Airtel SIM tomorrow, I'm not saying that you're partnering with Airtel today, but as an example, if you purchase an Airtel SIM today and put it inside your device, if you put it on a tracker device, as the tracker roams, as it goes through areas of cellular connectivity, it will connect to that tower. As soon as you lose connectivity, just like your SIM in your phone is able to switch, this tracker can now switch from the cellular connected device, cellular connected tower, to our satellite, and from the satellite it will be able to transport data. So this switching is as seamless today for NTN networks as you can think of for the cellular world today. So that is what we do. So what kind of use cases do these serve? As the theme said, these use cases are outdoor use cases ranging from infrastructure. So for example, if you have a pipeline grid running, if you have a power grid somewhere, if you have oil pipelines, if you have water pipelines, if you need to monitor those, these can be monitored today in a more cost-effective fashion using an NTN network like ours. It could also be used for things like asset tracking. Now conventionally when we think of asset tracking, we think of the GPS tracker that's in your car that tracks your location and sense. But interestingly enough, a lot of the asset tracking use cases that we hear about today from our customers today are what you would think of as very esoteric. So worldwide, the number of cattle and livestock runs into millions. Sometimes in some countries, the livestock is more than the number of people in the country. To be able to track that kind of livestock is extremely important. To be able to monitor the health conditions of that cattle is extremely important. So these are some of the use cases that NTN networks today can solve. And these are problems that are being solved today live. These are all real problems that are getting solved today. Along the same lines, as the last thing that I want to highlight and talk about, technology is there, networks are coming up, they're becoming live, devices are getting rolled out. Because the technology is changing so fast and rapidly, areas like regulation as well as mainly regulation, I would say. Regulation needs to improve and catch up very fast. Thankfully, governments worldwide, regulators worldwide have risen up to the challenge. A lot of the regulation has changed to keep up with it. As an example, what Mr. Agarwal said today, India Space Policy of 2023 makes it very much easier for NTN networks to come up and start serving customers globally. A lot more needs to be done in this area, and we hope
for ease of doing business. And in 2022, there were major satellite reforms. So I feel that, and I think that because it is a continuous process, so we will always be moving forward to address the concerns and challenges of the market. Thank you. So now I invite questions from the audience.
Mr. Agarwal, I'd like to speak to you on this. Can you hear? So, the connectivity in India is in certain areas where even the cellular is not reaching, but it's very essential, like in northeastern sector. And over there, I believe even the collectors of their districts, they are not connected. Now, the other side is disaster management. We have big fires in the forest, and we have not yet found out the solution through IoT devices we can get the sense and the feedback over there. So these opportunities which are becoming very big, because about a year back I was talking to the minister, that time minister, Mr. Rajiv Chandrasekhar. He was saying that we have to find solutions for the connectivity, where then what we are discussing here, all the members have discussed, how to reach to where the cellular is not reaching, but the usage would be more than the cellular requirement by the local population. So over there, how we can, as I'm from SI also and have my own company, how we can work together with the DOT and the operators and the members here to reach over there, because the solutions are not yet found.
Yeah. As regards your various concerns, DOT, Department of Telecom, has already taken various steps, like 4G saturation project is already underway. So under this project, all the villages are to be covered with 4G services. So about 25,000 villages are targeted to be connected. Now regarding the second part, so now because the space sector or the satellite sector, that is open to all, to private and the government, all entities can provide. So the industry can also come forward and can provide services, and in the future also consultations may be held, and based on the consultations we can move forward and come out with some kind of solutions. Thank you.
So we have an opportunity to come forward with our with the solutions by getting in touch with the ministries as well as the operators and the technology provider, right?
Yeah, so because now the policy formulation is a consultative process,
Right.
and even whenever any RFP is floated, then comments of the stakeholders are also invited. So it is a very transparent and participative process, as you know.
Thank you, Mr.
Sir, the solutions are available for like the use case you mentioned for the forest fires. The solutions are available, but it has to come through the MNOs. It is highly regulated market, so the solutions are available.
So we have to discuss this because the country is suffering. Even solutions have been found in Amazon. The forest fires. Road accidents. You had spoken about that vehicular traffic, and passenger trains, but yet we have accidents. So somewhere down the line, we'll have to show the importance of IoT through satellite, which will provide the solutions which is with the MNOs, because MNOs also don't understand. If you discuss with them, they say narrow band, what's the size? We are having over 300 million customers. You are talking
Of course, the volume is a matter of concern, but yes, the technology is available, these devices are available. Only my request to Arun Sahab is to give some ease on the MTCT and TEC, so that more and more devices can be imported and the solutions can be provided easily, even on the smaller scale.
So from SI also will participate with you to help in this.
Maybe one point I'll mention.
Sure. Yeah.
We have done, I cannot name at least one customer, but we have done at Skylo, we've done a pilot with a specific customer in the past, where they deployed sensors specifically in India, in a remote place for forest fire detection and prevention. So they were a they're basically a SI, who was basically trying to develop a solution for A, detecting forest fires, and B, reporting incidents of that. Second, we have worked in the past with the Indian Meteorology Department for the Northeast, where they have different monitoring stations that have been deployed, which today use alternative technologies for trying to use satellite connectivity for those. So those pilots have been very successful. I believe it's only a matter of timing to the extent that acceptability of NTN networks as a general technology available in the country today, it's only a matter of timing. As an example, if you spoke about NB-IoT, but NB-IoT today is an integral part of both the two main telecom operators in India. Both Airtel and Jio have a working NB-IoT deployment today for the large part in many parts of the country. And the interest in NB-IoT as a technology, even for cellular, for IoT, is slowly increasing. And I think it's only a matter of timing before some of these things can start showing up in actual field conditions.
I will just like to add that to give it more importance and to highlight the importance of satellite connectivity for IoT systems, more conferences specifically on this subject may be held so that there is awareness. Those solutions are already available, and I think connectivity is already available because satellites are available which can provide connectivity through VSAT in every part of the country. So we are running very much short of time. We are already much delayed. So we can now close if there is no very specific question. So I thank all the panelists and the audience for their patience and for their participation.
Thank you very much, Mr. Agarwal. This surely was the session full of enthusiasm, amazing presentations, and the expert viewpoints from our panelists. Thank you very much, everyone. I request our session chair, Mr. Agarwal, to please hand over the mementos to all our panelists as a token of love and appreciation. Firstly, to Mr. Gianluca Redolfi, thank you very much, sir, for your presentation and joining us today. To Mr. Jaswant Singh. Thank you, sir. To Mr. Prasanna S. Iyengar. Thank you very much, sir. And I would request Mr. Pavan Kapoor, board member, SIA-INDIA, to please join us on the stage and present a memento to our session chair. Thank you very much, Mr. Agarwal, for the lovely session. May I request all the panelists to please come forward for a group photograph. With this, ladies and gentlemen, we'll break here for lunch, and which is right outside the hall, and we'll see you right in 15 minutes for the next session. Thank you very much.